Hi, everyone. Just wanted to take a minute to talk a little bit about factoring shortcuts. In particular, we're going to start with the difference of perfect squares, and then we'll briefly look at what happens when you have a squared trinomial. So when you look at this immediately, what do you see? You see an x squared minus 49. So you already noticed you were missing the b term, which is something you've seen before, right? You knew in the past when you had something like this, right, when you don't have a b term, right, it would be something like this, minus a x plus a, right? Whatever the value is, would factor out, you'd end up getting x squared minus a squared. So that's all that we're going to do here. When you end up with something like this, you can easily factor it. It's just going to end up being x minus 7, x plus 7, and you're done. You don't even have to worry about going through the process of finding, factors of each that add up. You can do it, it'll work. And to illustrate what I mean by that, of course it'll work, right? So if I look at this, I have to find factors of negative 49 that add up to 0. What are my factors of negative 49? Right, I have negative 1 and 49. Well, that clearly doesn't work. I have 1 and negative 49, which again still does not work. I have negative 7 and 7, which already works right there. So ultimately, your answer just ends up being x minus 7, x plus 7 anyway. So as you can tell here, when you look at this, if you end up with a difference of perfect squares, you can just write your answer as, x plus 7, x minus 7. Now, if there's something like this, right, I don't need to do a whole lot once again. I can just look at it, go, okay, this is the difference of perfect squares, x plus 5, x minus 5. Okay. Now, this one's a little bit tougher, but I assure you it still is the difference of perfect squares. And the reason it is still the difference of perfect squares kind of comes down to the fact that this is 5 squared, right? This here is 5 squared minus 8x squared. So when you have something like that, what it ends up being, right? You're going to have 5 minus 8x, 5 plus 8x. Same thing. No difference. Okay, even though the order is a little bit weird, you can still do this process. 5 minus 8x. Also, by the way, you can rewrite it. 5 plus 8x. Double check, make sure we did that right. Yep, exactly. As you can see here, it is the difference of perfect squares. So you just have to rewrite it as something like that. Now, as you might recall, you also have the other kind of special case, x plus a squared, which was equal to x squared, right? X plus a times x plus a, x squared plus 2ax plus a squared. So once again, if you still see that pattern, the square binomials, right? You still see this pattern. If you see something, for example, like, x squared 49 plus 14x, right? That would still work. If I gave you this, you could just easily tell me the answer is just going to end up being x plus 7 squared. And the reason why ultimately comes down to the fact that this is 7 squared, this is x squared, and this is 2 times 7 times x. You could even end up with a slightly trickier one, right? Like if I gave you something like 9x squared, 25, right? Minus 30x. This might not be readily present, but whenever you see a perfect square up front and you see a perfect square in the back, ultimately you should be on the lookout. And the reason you should comes down to the fact that, what's this? This is 3x squared. This is minus 2, or, well, this is, what is this? Plus 2 times, 3x times negative 5. And this is negative 5 squared, right? It all comes out the same. So you're going to have 3x minus 5 squared. Okay. So that is just another special case. Ultimately, you can still go through the same process, right? If you see this, it might not be readily apparent that you can simplify that right away. So you might still do 9 times 25, which is, 225, and then find factors of 225 that add up to 30. As it turns out, the answer is 15 times 15, or negative 30, I should say. So negative 15, negative 15. And you're going to end up with about the same thing. All right. So just keep that in mind. And ultimately, those are some of the special cases of factoring. All right. Let me know if you have any questions, and have a great day.